Yeah, so we've got, in terms of the schedule, we've got kind of similar to yesterday, I guess. We've got a long session to begin with. Of course, there'll be some moments of sort of, at least sort of semi-break while you, well, not really break for me from talking, but while you try the challenges, and then another session before lunch. Okay, so we'll see how far we get. So, close this. Okay, so where were we? We got to, oh, let me hide this thing here. So we got to this sixth session. I think the URLs, see, if you look at the URLs, it's a bit confusing because the URL says file number is 05, but actually it's now the sixth section in their progression of episodes, say. So it's a nice little reminder. So we had the introduction to generally to Python, starting off with data, plotting, doing some simple plots with pandas, directly from pandas. Then we looked at how to index, slice, and subset, so basically applying criteria for selecting data. Then we looked at types of data and formats and writing out. And we just started looking at how to do something a bit more sophisticated with handling more than one data frame. So that's where we're at, combining data frames. So I started sketching yesterday one situation where you might want to do this. We talked about these two. So let's just get stuck in. So we had multiple files. So let's start by importing pandas as usual as PD, and then let's read in the same surveys data file as yesterday. So I'm going to do a little comparison. I tried to do a comparison yesterday between reading the CSV without any explicit specification of any options other than the file name, as in the previous lessons, episodes, versus using these additional specifications, which they claim here in the comments doesn't change anything. So there is actually a way to compare the difference a bit more directly. So if I read the CSV file using the syntax they suggest with the additional options, and also create a new variable, options, without any options. Okay, so I've got these two data frames now, surveys df and surveys df, no options. So I can actually do let's see, pd dot equals, what is that? Pd dot data frame equals. So this is a function which the documentation shows test whether two objects contain the same elements, allows two pandas series or two pandas data frames to be compared against each other to see if they have the same shape and elements. Okay, so let's call it on. So I think we need to call it on an instance on one of the data frames. But let's see if this works. I don't think this will work. Let's try it. So I'm telling it to compare whether it's equal, whether these two are equal. Okay, that works, yeah. Okay, so that just confirms what I claimed yesterday and what the documentation, what this material also says, which is that it doesn't actually matter whether we had specified these additional options. So in other words, these do actually correspond to the default options. Okay, so I'm just going to leave them out from now on. So that's a good check. So I'll leave them out from now on. I'll just work with I'm going to reread that as to use a shorter variable name as surveys df. Okay, so that was our surveys file. We had that already looked at yesterday, and we had this additional file which is much smaller. The surveys data file was about 30,000, 35,000 rows. This species data file is much smaller. Data frame, we'll read it as CSV. And again, I'm not going to specify any arguments, and that as you can see, it's kind of a list. I should print all of it because it's not very large, so you can just see all of it. So this is for each 2-letter species ID. There's one row, so there's 53 species IDs, and for each of those it has some additional information. Okay. So let's look first at the case where you're concatenating data frames, which means pending either columns or rows from one data frame to another. So there's a kind of 2 use cases. So let's look first at, well, that's okay. So as I suggest, let's grab some subsets of our data to make it a little bit easier to see. So let's create this subset of our service data frame, which just takes, so far we used head without any input argument. And that gave us the, well, how many did it give us? Length of service sub. 5, okay, so we're going to say you can specify an input argument to have more than the default. So now we've got 10, we've just selected 10 of the entries, first 10 entries of that data frame. Okay, and also we want the last 10 entries, sub last 10 equals data frame 10. Okay, just to print that out. Oh, typo. Okay, so as you can see, the record IDs correspond, sorry, not the record IDs, the indices here, offset by 1 from the record ID. So you can see there's kind of a superfluous thing here. So these record, just to be clear, I mean, I can't remember if this was discussed yesterday or not, but these record IDs here, they're a genuine part of the data. They are there in the CSV file, right? These in the index values, those are added by pandas when it constructs the data frame. And actually, as we'll see when we do some of these operations, when we combine rows from different data frames, which have their index values determined by, for example, the fact that this, this survey sub last 10, these indices correspond to the final 10 values of the indices in the surveys data frame. But you may want to, if you can put those somewhere else, if you combine them with some other data frame, you'll have to, how would you say, maybe normalize the indices, and there's a way to do that to make sure they all sort of number sequentially all the entries consecutively in a new data frame that you construct. This is exactly the next step, actually. So yeah, so after you grab the last 10 rows, it just resets the index values so the second data frame appends properly. So the point being that we're going to just make this into, so we're going to say survey sub last 10. We're going to actually last 10 dot reset, and reset index is the function. And if we don't use drop equals true, let's see what we get. If we just do reset index, what do we get? Typo. In fact, see surface. Got a couple of typos here. There we go. So if we don't do this, if we don't pass this drop equals true option, then we've got now we have an actual column labeled index with our original indices, and then we've got a new unlabeled column, which is just the index, a new reset index. So we don't want that. So I'm gonna grab service sub last 10 again from scratch, and then reset index with the option drop equals true, and that just says drop the old indices and just keep the ones that you've reset. So now survey sub last 10 still has the original record IDs from the original data frame that it came from, but it doesn't have this additional index column. Okay, so this is talking about what something we'll actually use in a second when we concatenate data frames. So the idea is basically we've got these two subsets, two sets of 10 entries from the beginning of the survey's data frame, 10 entries from the end of the survey's data frame, and we're basically going to stick those together and create a single data frame out of both of those. And we're going to stick them together by concatenation. We're basically having the 10 rows on the first one, and then the second set of 10 rows from the second data frame, combine those into a single data frame. So as it says here, so when we do concatenation of data frames, you need to specify the axis, and the axis basically tells you whether you're trying to stack or combine data frames vertically or horizontally. In other words, whether you're adding the rows of the second below the rows of the first, or whether you're adding the columns column-wise. So each row is continued from the first to the second set, and you're adding the columns of the second set after the columns of the first set. So that refers to the axis. And actually, you can specify. Well, we'll do it, and then we'll show it an option. So first of all, if you're going to stack the data vertically, as we're trying to do here, first of all, just the rows of this first set and the rows of the second set, they need to make sure they have the same columns and the same column format. You'll probably get an error if that doesn't match. We know that they do have the same columns here, and there should be no issue at all stacking them because they're both drawn from the same original data frame, right? So in general, of course, you might have to do some checks or some pre-processing or whatever to make that be the case. Yeah. Okay. So how do we do this? We say vertical stack is pd.concat, so the concatenate function. And what does that expect? It expects a list of the. I suspect you can concatenate more than just two, right? So it's a list of, and well, we'll see if we just check out the documentation. pd.concat question mark. Okay, so objects. Options. Okay. A sequence, so the object parameters, the first one is a sequence or a mapping of series or data frame objects. Yeah, so it doesn't say anything about two, it says a sequence, so what should work for more than one. So I'm going to go ahead and do that. Vertical stack is pd.concat, a list starting with the first 10 entries subset, then the second 10 entries subset. That's our list, and then there's the specification of the axis. The axis is, like we just said, whether you're stacking vertically or horizontally. And if we look at the documentation here, which is still open here from when I issued that, the axis argument, here the axis argument, like it says here, is either 0 or 1. It tells you the axis to concatenate along. Now, I actually find it easier to remember to use, so you can use either 0 or the label index, and either 1 or the label columns. So if you can't remember 0, what 0 or 1 corresponds to, it's easier to just, I find this easier to remember. So if you think you want to concatenate along the index, then you just say index, axis equals index. If you want to concatenate along the columns, then you say axis equals columns. So instead of saying axis equals 0, I'm just going to do that because it's easier to remember. So axis equals index. That's it. Okay, so let's have a look at that. Okay, so that seems to have worked in the sense that we've got the first 10 entries from the original data frame and the second 10 entries from the original data frame. Clearly, you can see the record IDs are reflect that, 1 through 10, 3, 5, 50, 55, 40 to 55, 49. Now these indices, in a sense, maybe there was no point in having reset the index for the second subset if all we were going to do was eventually add it to the first subset, because although we reset the index, it went to make it go from 0 to 9 instead of 3, 5, 5, 4, 9, 4, 0 to 3, 5, 4, 9. We're offset by 1. It's now still wrong in the eventual data frame, so we're going to have to do another reset of our index, like it says here. So have a look. Do you notice anything unusual? The row indices have been repeated, and so we can re-index a new data frame using the reset index method. So if we do vertical stack dot reset index, and we should make sure that we say crop equals true again, otherwise we're going to end up with 2 index columns. Okay, so now our index goes from 0 to 19 as we want. So I'm just going to add that on, knowing that works, gives me the right thing. I'm going to add it on to the original definition of the vertical stack. In one go, reset the index when I originally loaded, or when I originally created and assigned it to vertical stack, and then vertical stack again. That's ended up how it should be. Similarly, if we want to do a horizontal stack, let's try that. Cat, again a list, survey sub last 10. Axis now is, I'm going to call it columns. Oh, is it column or columns? I'll get it wrong, let's see. Okay, it's just a typo there. Okay, and let's see what that looks like. Oops. Okay, so this isn't, oops, the scrolling thing issues come up again. Ah, that's very strange, very strange. Here we go. So it's clear that there are only 9 rows, as we expect. We may need to scroll a bit to the right to see what's happened. So these first 1, 2, 3, 4, 5, 6, 7, 8, 9. These columns are the columns from the first subset, and then what we've got is the columns of the second subset. Yeah, so we've got here what's something we don't want. Of course, in the first case, when we're stacking vertically, we had to re-index the indices. Now that we're stacking the columns, what happened is that the index from the second subset has been appended as a column, which we don't need, we don't want, doesn't tell us anything useful. So we want to get rid of that. So there's actually an option here. It says let's see, well, we can either select that out. Let's see. Let's see if there's an easy way to kind of immediately to not include that in the if true, do not use the index. This looks promising. Ignore index. Let's see if that works. Otherwise, there are other ways to do it, which I won't, let you try yourselves. You can think that ways that you just filter out all the data apart from that column. In an additional step, ignore underscore index. Let's see. Okay, so now this is not what we want. So what it's done is it's actually ignored the column headers of the first both files actually, which is not what we want. Anyway, there's ways to get around this, but it's not sort of big issue for now. Okay, right. So you can write this out. Yeah, if you want, you can write this out to CSV, and it's suggesting that you do so and then tell it to if we want to write the vertical stack and do under to CSV, data out to CSV. We can say index equals false there to tell it to not write out the index. So let's try that. So we use the magic ls command, which won't always work. It's not a general Python command, as I said yesterday. It's one of these hacks that, for convenience, that something in an environment like Jupyter Notebook or the IPython wrapper to the Python interpreter, it's what they provide as magic commands that just work even though they're shell commands. So let's see what's there. This data. So we can see that out.csv is there. I can even cat from here, even though that's just also a terminal command. Data out.csv. Okay, so that's the subset with the record IDs. You can see that the index there from 0 through 19 has been left out because we requested index equals false. Okay, you can read that back in again, etc., etc. So here's the first thing for you to try yourself, and I'll just give you plenty of time for this because it's the first exercise of the day, just getting stuck back in. So this challenge here, have a go and come back at let's say 10 o'clock, and just a little bit after 10 o'clock, I'll come check back, see how people are going to go with that, look over it. Have a go at that exercise and try it out. So let's have a look at how to do this. So it's saying that there's two files, and you need to read in each of them to get data frames. So we're going to surveys. I'll use the same notation that they use in the example solution here, just for the survey 2001. I'm going to read in. Read it in pd.read CSV data, and I think I've got it here directly under surveys one rather than yearly surveys, and likewise for the 2002 survey data. Okay, so I've got my two data frames, one for 2001 and one for 2002. Combine the files to make one new data frame. Okay, so I'm going to do pd.concat. I'm going to pass the list of the survey 2001 and the survey 2002, and the axis is, well, these are 2 years, the same kind of measurements, so just successive rows, right? So stacking vertically. So I'm going to stack by index. The axis equals the index, and let's see what happens. Okay, right. So what is a little bit hidden here is clear that the index isn't going to be yeah, we need to, in principle, we know that the index here, this is going to be not consecutive. It's going to jump presumably, yeah, it's going to jump because the survey 2002 index starts at 0 and goes to the largest value within 2002 data, and the 2001 index starts at 0 and goes to the largest value 2001 data. So we could reset, like we've done before, reset the index on this new data frame that we've created. It actually doesn't matter for the purposes of plotting, because if you think about it, when we plot stuff, we're being very clear about which fields we want to plot, and it's not simply it's not using that index in the plot. We can go reset the index as before. Prop equals true. So then we end up with properly labeled, properly indexed new data frame. And if we want to plot, what is it asking us to plot? A plot average plot weight by year, grouped by sex. So we're going to have to do some grouping. If you recall from yesterday, I'm going to use a slightly different, only very slightly different approach from here, just introducing some, just giving intermediate variable names, I think, make it a little bit more explicit. So we're going to group things by sex and year. So I'm going to take the surveys. I've not actually named, actually assigned this combined single data frame to anything. Combined. Okay, so that's a surveys combined. That's grouped by. I'm going to group by what it says by year and by sex. So that's a logical grouping of the information, and yeah, so I'll just create the logical grouping, and then I'll create another variable called the mean weights by sex and year. Is that groups data? And I could do this on a single line, but this is just to be super explicit. So you take the weight from that logical grouping, and then compute the mean metric. Oh, just look at that. What does that look like? Looks like the kind of thing we want, right? It's by year, by sex, it's the mean weight. As we had a couple of times already yesterday, we saw that if we wanted to plot this as a bar plot, we have to unfold it, we have to unstack it. So if we unstack it, we've got the columns and rows, got this two-level columns as columns and rows, and then we can plot it using plot. Dot plot kind equals bar. Okay. Okay. I mean, it looks like what we expect, suggesting this tight layout thing, which we can try. Let's see what happens. Yeah, that's what I thought. This plot was not defined. I don't know if anybody already had a look at the solution and tried that. So that's a matplotlib thing, which we've not talked about. Yeah, so I forget that for now. It seems to look fine anyway, even without that. So this may be a historical thing. So yeah, this involves matplotlib and pyplot. So you can forget about that. Okay, if we want to write it out to file, then we can say we can just mean weights by sex dot to CSV. Let's call it weights 2001-2 CSV, and I'm not going to store the index. Okay, let's do our shell hack to see what comes out. Okay, that's very simple. In fact, we're probably missing out some information, right? So that's what it's actually storing here, writing to CSV. It's storing, writing to file the weight year, which the solution here has defined as as the unstacked. Okay, as the unstacked data. So that should be fine. But if I do store the index, right, we retain. So in this case, the index is not just simple sequential numbering, which is like a duplicate of the record ID in the case of the original data frames. Now the index is actually relevant, right? Because now if we say index is false, we're not writing out actually the year and the sex information. We've completely lost that, which we don't want. We want to keep that in the file, right? So yeah. I see it's automatically added. Oh, no, okay, so that's just fine. Okay. Any issues with that whatsoever? Any questions about that? Just say in the chat. Of course, you can unmute as well if you like. Just ask. If not, then we will go ahead. Okay, so far we were concatenating data frames, and like it says, essentially just adding more data to make up a new data frame. Another way to combine data frames is, instead of this sort of straightforward stacking of one set followed by the other, we've got two data frames, is to use some logic for how to join the data. Like it says here, another way to combine data frames is to use to do so on the basis of one or more columns in each data set that contain common values. So there's a common unique identifier. And then you're basically joining the two sets of data on the basis of that common data, on the basis of the appearance of common values, so known as a join key. And one context in which you might want to do that is the one I started by sketching yesterday already, which is where one data frame might be a lookup table with additional information that you might want to include in the other, might want to include in or combine with the information in the first. So this is describing here what I said yesterday about this lookup idea. And like it says, it's basically, so the example here is where your survey data contains for each recording, for each record in the survey, you've got a note of the two-letter species ID. And there's all kinds of other information associated with the species ID that, in principle, you might want to combine with the survey information, but you don't have to literally record that information every time for every record in the survey information where you have any given species ID, because that would just be duplication of data. So instead, the species, a separate file, separate data frame, the species data frame, which we already created earlier on, stores that species-specific information as a kind of lookup thing, so that when you want to combine the information from the survey with the information about a species that's independent of the particular survey, you can do so, and that's essentially what we're going to do now. So we start off by looking at how to join two data frames. So I think we still have this subset of the surveys, but data frame, let's just grab it again. So that was the first 10 values of the surveys data. And here, the idea is as well, you keep a subset, create a subset of the species data rather than the full value. So there's a special file here, species subset, which contains, let's see if we can find it here, data species subset. So without even reading it in, I'm using this magic command cat to just quickly inspect the files. As you can see, that species subset file just contains species information for 3 species IDs. So that's what we're going to work with. So our species subset data frame is pd.read CSV data species subset. And I'm not going to specify these additional optional arguments because they are actually the same as the defaults. So I'm just going to read them in like that. So the species subset is a lookup table containing genus, species, and taxa names that we want to join with the data in the survey subset to produce a new data frame that contains all of the columns from both species DF and survey DF. So it contains all of the columns, but now what we're not doing is simply taking. It's not the case where we've got 10 rows from one data frame and 10 rows of another data frame, and we're just sticking the columns of that second data frame after the rows of the first data frame. It's a bit more intelligent than that, or a bit more sophisticated. We've got just 3 rows in our second data frame. Those 3 rows correspond to each row in the second data frame is a particular species ID, and wherever that species ID occurs in the species ID column in the first data frame, we want to add in the correct values for that species ID to additional columns in a new data frame. Right? So we're going to create a new data frame that has the additional columns that are present in the second data frame, namely genus, species, full name, say, and taxa. And for values in for each so wherever DM occurs, for example, as a species ID in the first data frame, then the genus, species, and taxa should be these values looked up from the species subset. So how do we do that? Okay, so we first need to identify the join keys that we need to know which fields are shared between the files. Now, clearly, as we've already discussed, it's the species ID that is the correct join key. So it says if we're lucky, both data frames will have columns with the same name already that contains the same data. So that's the case here. The species ID column is present and identically named in both data frames. So that makes our life a little bit more easy. If not, you need to identify what is the right one to combine, and need to just a little bit more specification to do that. So this is just showing that. So we've got the columns in the species subset include species ID, and the columns in the survey data frame also include species ID, right? So species ID is the join key for this case. Now, there are different ways to join 2 data frames. And the most common type, as it says here, is called an inner join. So the idea is if you've got 2 data frames and you're creating a new one where you're taking additional information, then then what you're doing is you're deciding whether, so for values, so you've got different choices. What you can do is if there's cases where there's a species ID that occurs in the second data frame, but not in the first data frame, then you could put in the you could create a new data frame where where those values where you do insert those values, but of course there's where you do insert the values that you have from the species ID, which is the genus, species, and taxa. But there's no record from the survey that corresponds to that, right? So there's no, you'll have no information for any of the things you actually care about. For records where in the survey where there's a species ID noted down that does not appear in the species data frame, you have a choice. You could say, well, I don't have any information like genus, taxa, species, and taxa about corresponding to this species ID. However, in my new data frame, I'm still going to keep the original survey data, because even though I don't know the additional species information, I still want to record the fact that species was present at this particular site. But the third option is more common, is cases where your new data frame, and now we're talking about an inner join, that's this overlapping subset where the species ID, where the join key, in this case the species ID, is present in both the survey data and the species data. So in other words, the more typical choice would be where the join of these two data frames results in a new data frame that is a subset of both the survey record information and a subset potentially of the species information, of the species IDs. And essentially what you're doing there is you're saying for any survey records where there was a species ID recorded for which I don't have any data in the species data frame, leave that out of my new data frame. Don't include that data, because clearly, in this case, the setup is I care about the species information like genus, species, and taxa. I need to have that available for any records in the survey that for which I don't have that species information available in the second data frame, in the species data frame. Don't include those in my new data frame in the join of the two data frames, because I need that. And if it's not present, forget about it. I'm not going to use that data, right? So that's the inner join. So how to actually do that in pandas? Instead of this function being called join, it's called merge, and doing it with the option to discard any entries from either a data frame actually where there's no information. That's called the inner join. Because conversely, just like saying I don't want to include any records where I don't have species information, I also don't want to include any records where I don't want to include any cases where there's species noted down in the species information for which I don't have any records, right? So that's the inner join. So that's the default. So how do we actually do that? It's as follows. So we say we're going to do a merge, an inner merge. I'm going to do that by saying pd.merge. And now we need to specify the following options. So what are we doing? We're merging two data frames to create a new one. We've got the first one, so let's say the one on the left, and the second one is the one on the right. So that's what these input arguments correspond to. So we say left is the survey subset of our survey data, survey sub, and the one on the right is the subset of our species data, species subset data frame. Okay, so those are two data frame specifications. And then the next specification is, and actually pandas will figure this out by itself if you don't specify it, because there's a single unambiguous join key, but we're going to be explicit about this because it's clearer, and you know that for definitely it's doing the right thing. It just helps understand and clarify what's actually happening. We're going to specify the key to join on as it's called in the left data frame, namely species ID. And we're going to tell pandas what that join key is called in the right data frame, specifying right, the join on as in the right on or left on is what key to join on. So we know it's the same thing in both cases. We're still going to specify it just to be super explicit. Okay, so if we do that, let's have a look at the result. Merge inner. Okay, so if you if you remember, we started off with the survey sub was 10 records from index 0 to 1. Species sub was 3 species ID, and now our merged inner, it has 8 records, not 10 but 8. So 2 have been left out. So the ones that have been left out will be ones where there was a species ID. If we compare it to the original, so you see species IDs, what are NL, DM, PE, PF. What is missing? PE, PF. You see there's an entry here with PF, another entry here with PF in the original data. Now in our species subset, we had 3 species IDs, DM, NL, and PE. We did not have species ID PF. So in our inner join, this merged inner result, we therefore, in this data frame, we've excluded and left out the entries from our survey subset that had PF as a species ID. Right, so that's the logic of the inner join. As shown here, if you look at the shape, it's got 8 entries as compared to the original survey. So it only contains rows that have 2-letter species codes that are the same in both survey sub and species sub. Okay. We didn't have any species IDs that do appear here in the species data and don't appear in the survey data. So DM, NL, and PE, all 3 of those appear in the survey data. Okay, so and clearly what's happened is that I mean, it's restricted. We've restricted. Now we've got fewer records, but the additional data of genus, species, and taxa have now been added to this data set appropriately. So we've enriched our data set with the correct values for each of these 3 columns, depending on conditionally on the species ID value for each row. Right. So it's a more logical, sort of a more sophisticated logical way of joining the information from 2 data frames. As it says here, fewer rows. Okay. Another option we have is to do not an inner join, but a left join, or also called left outer join. So the idea here is that even if you don't have species information in the for any of the rows, for some of the rows in the original survey data, you still include. You don't ditch the data. You keep it there, and it appears in the results. So let's do that. Let's do a left merge. Merge left is field merge. Same data frames as before. And now we have an additional input argument which specifies the kind of merge to do, the kind of join to do. We didn't specify this before because we were using the default, and the default for pandas merge is to do the inner join. But now we specify a different option, which is to say how left. So we do a left join as it describes. So we keep entries from the left regardless. And still let's see if without specifying the join key, if it'll work it out correctly, right? So I'm not going to specify left on and right on. Let's have a look at merge left. Let's see if that's worked. Okay, so now our merge left has 10 records, like the original survey subset. You can see the records where the species ID is PF still appear. They've not been left out. For those rows with PF, you can see that the genus, species, and taxa data is missing, not a number, right? So that's fine. We know that when we do some logical operations, if this was numerical information, those things would be skipped in aggregate statistics. And clearly, if you try to plot stuff, or not numbers will either be skipped or will stand out. So you've still enriched your data set, and you've kept the original records for which there's no enrichment possible, but it's done sort of the clear tracking thing, which is made those nans. It's not added some random choice of species, or taken, say, the first entry or anything silly like that. So that's useful, and clearly it's worked. Us not specifying left on or right on as a join key has worked. Pandas has identified by itself that there's a common column ID in these two data sets called species ID, and it's done the join on the basis of that. So you can see that we could have left that out in principle. That's basically what it's saying there. And if you want to see make very explicit, if you've done this for a much larger data set where it's not as easy to maybe spot what's happened. I'll call it merge left rather than merge left. So you can check where, for example, there are missing values. So where you've not been able to enrich the data by checking for where one of these fields, like for example the genus, where it's true conditionally that is. Okay, so again, we're just using the selection criteria approach from yesterday. Give me all the values, all the entries in merge left, where the genus field is not the number, and that just picks out those two rows which you already identified visually. Okay. So, of course, there's other. Well, of course, I mean, I already described one other join type, which is the right join, which in this case would be somewhat counterproductive, probably. It's just the same logic as left join, but then applied to the right case. And a full join is an outer where you just have everything, all options, so-called Cartesian product. So yeah, it's not very rare, not very commonly used. And you can also join with self, and there's a link there to find out more about there. Okay, so now it's time to take, and this might take a while. So I would say, let's forget about this diversity challenge, because I think this second challenge here is really a much. I don't think it teaches necessarily that much more, or gives that much more insight to the actual methodology. It's probably a very nice exercise for ecologists to do. You may have spotted already that although this course is advertised as data analysis and visualization using Python, it's actually the carpentries lesson is actually Python for ecologists, or let's see, what's it called? Data analysis and visualization in Python for ecologists. So whereas this is a very nice exercise, undoubtedly, for ecologists to do. And I don't think any of you are. I think I saw the chart that none of you are doing ecology. So I would suggest skipping this second challenge, but doing this first challenge. It's not necessarily that clear what it actually wants for taxa by plot, because there's different ways of interpreting what it means for, does it say number of taxa or number of records for a given taxa per plot? So there's different ways of interpreting that. Anyway, there's two things to try and plot here, and this is a fairly, it could take a while, and just talked for a long time and just introduced a whole lot of stuff about these merge stuff. So take plenty of time to have a go at this yourself. Let's look at this just to finish off by 11 o'clock for our break. So let's look at this at 10 to 11. Yeah. Okay, so like I said, it's so the phrasing of this maybe is a little bit unclear. There's multiple ways to interpret really what it's asking for. It's saying the distribution of taxa by plot. So you could interpret it as the number of species of each taxa per plot. So if that's what you care about, that's really what you're trying to show, is then think about what kind of merge we want. So we've got our surveys.csv. We already loaded that. Surveys data frame. So we've got that. Right, and we've got our species data frame, the full, not the subsets now, the full sets. But let's think about what kind of merge we want. You actually, so a left merge is actually fine, because whereas you definitely need the site information from the surveys to determine the plot ID. That's what you want to plot. You don't actually mind necessarily if the taxa are unknown. So you want to keep the records from the original data. So the kind of merge you want to do would be a left merge. So the merge data frame would be pd.merge with left being equal to the surveys data frame, the right being equal to the species data frame. Then how it would be left. And I'm not going to specify the join key because pandas can work that out by itself. That is the species ID. So that's our merge data frame. And then, like before, we wanted to taxa by plot. So we want to group, let's say, merge data frame. We want to group that by what? The plot ID. Once we've grouped it by the plot ID, that's a logical grouping. What do we actually want to plot or measure? One thing would be the taxa, right? So that's a logical thing. And then what we want to do is to get the number of unique taxa. So if you just simply count the number of taxa non-unique, then that is essentially capturing the number of times that any taxa information is present. So the n unique number of unique call will give you that. Right. So this is for each. What we've got is with grouped our data, we've asked it to tell us the number of unique taxa for each plot ID. And all that's needed is to just go ahead and plot that. Okay. So the other, there's a suggestion here. So another way to interpret what the question is asking for is the number of individuals for each taxa and each plot. So for that, you would be grouping, you group not just by plot ID, but also by taxa, and then you'd count the number of records for which that's the case. And then you'll need an unstack, as usual, because you group now to two levels, plot ID and taxa. And if you do that, go ahead and do that, plot it with stack is true, then that will give you this. The sex by plot is a little bit ambiguous, and it's a bit complicated because the suggestion they give is a pivot table. I've not found a nice solution to sort of present that doesn't use a pivot table, doesn't require explanation of the pivot table. So this will work as an approach for that. It's a little bit convoluted. I'll see in the break if I can find a nice explanation for this case. But feel free to share if you've already worked out a nice way to do this. On the I guess the chat is a bit awkward to do that. I'll post in the Etherpad link. There we go. That's the shared Etherpad, which we haven't really been using. But if you've got an approach for how to do that, the second one, taxa by sex by plot, feel free to paste it in during the break. And as I said, let's not bother about this biodiversity exercise. So, yeah, they give you some practice with how to use merge to combine information from two data frames, for example, enriching the information in one with the information from the second one. Also how to do simple combinations with concats in both dimensions. Told you about the different kinds of logical joins you can do, and writing out CSV files again. Okay, so we'll break and we'll start again at 1:15. Yeah, see you at 1:15. Okay, so I've not yet come up with a nice alternative to the solution, example solution for this second exercise here. I'll look over lunch again to see if there's a nicer way to do this, apart from using a pivot table, something a bit simpler. But let's continue on to the next episode. So this is episode 7, data workflows automation. Okay, so this is really about streamlining some of the stuff that once you've figured out and prototyped how to load your data, how to maybe clean it up, how to deal with it, how to process some stuff, to combine those things to a pipeline that you can just rerun, so that you essentially create, this is useful because you can create a set of Python scripts or one or more Python scripts where you start to predefine some functions, or define some functions that you can just use over and over again to help you to go push through a workflow. So say you're running a set of computational experiments, and often you're sweeping through some kind of parameter space. And I guess what you want to be able to do is, you might, for example, do multiple runs for a set of parameters, and then create a script with some that you can just use to load up all the data from however many runs you've generated from your experiments, to do some post-processing automatically, to do some maybe statistical aggregation, visualization, and then to write those files out, so that ideally, you run a bunch of experiments, and you could, of course, create some scripts as well to automate that. So you run some experiments, and then you just press go on the post-processing visualization, and maybe just very quickly have a workflow where you're automatically generating a set of visualizations for a given set of experiments to allow you to iterate on what you're investigating, and designing, and what choice you make next, and standardizing those into a set of scripts and automating things as part of a workflow is really just a way to make everything both less, more concrete, also reproducible, so you know that you haven't made up a mistake here or there, and what you're seeing is, if you've done it once, you've checked it out, it works, you can just push go and have it generate everything quickly, automatically, in a batch style, and come back and have a look at all your results of your latest run of experiments. So this episode therefore is looking at how to do that, how to start automating things and building reusable code that includes data analysis and visualization. So one of the ways in doing that is to basically, often you want to do something multiple times. You want to do the same thing multiple times for different instances. For example, we've looked at loading multiple files, one for each year from the first survey data. We manually did that in surveys 2001 and surveys 2002 CSV files. We had a line of code that read in surveys 2001 and a line of code that read in surveys 2002, and then we did stuff with that manually, interactively. But let's try and work towards automating this. So one way to do that is by using loops to repeat things, the same thing multiple times programmatically, rather than having individual lines of code with hardwired gears and things like that. So to be more flexible, basically, to automate, to repeat, and to be more flexible whilst doing so. So here's an example. Let's look at how loops work. So if we create a list, Python list, starts with square brackets, line, tiger, crocodile, vulture. Okay, I don't need to do print. I can just do, well, it's because IPython or Jupyter Notebook. If this was a Python script, you'd have to say print the thing, or just the thing itself. Anyway, so that shows us that's our list. Okay. So how can we? So obviously we know that we can access any given entry in that list with indexing, as we've done before, right? New range, etc. We know all about that. So now let's iterate over that list. So let's do something for the entries in that list. So in a for loop, we can create a for loop, and as you see, this is a reserved keyword, reserved word for. So Python will you can construct for loops with Python that iterate over objects that are iterable. Now a list is an iterable object, which means in Python you can iterate over it with the following syntax, saying for some variable name, whatever you want to call it, for a creature, in this case called a creature, in. So for and in are both keywords. For creature in our list called animals, colon is important as well to denote that the next line is going to indicate, next few lines are going to indicate what to actually do. Let's print a creature. Again, because this is Jupyter Notebook, we don't need to say print explicitly, but let's just do it because in the Python script you would need to. If I press enter again, that'll give me to the next line, which is indented. So if you don't know, I mean, indentation is relevant in Python. So Python doesn't have, other programming languages. You've got things like brackets to indicate code nesting, to define the scope of a block of code. But in Python, indenting is the way it works. So that indenting is syntactically relevant. So in other words, this 2, 3, 4, these 4 spaces here, it doesn't have to be 4, but these 4 spaces here are syntactically relevant and indicate this indentation offset indicates that everything that's indented is within the block of code that will be executed every time this for loop. Every time there's one iteration of this for loop. So what do we do with every iteration of this for loop? We print creature. In principle, we could do something else, but I'm just going to leave it at that. So press enter again. No, it won't take us back to the next slide. So, okay, we don't need an end for. We just finish like that and shift enter to start. So that's done a for loop, and each iteration is printed out the successive creature. So you can see that this for loop is iterating over the entries of our iterable object, the entries of our animals list. Okay. Yeah, this creature, which is an arbitrary variable name, you can call it anything you like, obviously. Obviously, I mean, the name suggests it's not a reserved keyword. And after this loop finishes, you can see that this creature variable still exists, and it's got the value assigned to it, which is the final value it had. So each iteration, it will have a different value, and after the loop finishes, it still exists, and it has the value that it had at the last iteration of the for loop. So this example here shows that. Right. So here, the idea is okay. Pass here, that's quite unusual. So in principle, you could this is to do nothing, which can be useful if you want to yeah, this is to show what happens to this. This whole setup is to show what happens to the creature variable. So if I do that, we're going to leave animals. We don't need to redefine animals. Animals is animals is still what it was. We haven't changed animals. We just iterated over the elements of animals. So if I now create another for loop for creature and animals, and I say pass, so pass it basically does nothing. You might say, why do I need to specify anything? Well, if you don't specify anything, you try to execute it. So say incomplete input. So it wants something. So this thing which you hardly ever really use in reality, it's just for debugging and for showing, demonstrating something. Pass will just do nothing and be happy. So now for creature and animals, pass and do nothing. Don't print. Don't print the creature. It's just to show the creature has still advanced. So just making it very explicit that this change in iteration loop variable is still happening despite the fact that we didn't do anything with it. Okay, so challenges. So the first thing is what happens if we don't include the pass statement. Well, I already showed you what happens. It says incomplete. And yeah, have a go. A couple of minutes to try this second bit. We'll just yeah, look again at 2 minutes time or so. Okay, so maybe you had a chance to have a go at that. So like I said, if you don't include pass, it will complain because there's nothing happening in the loop body, the main specification of what to do in the loop. Now the question is rewrite the loop so that the animals are output separated by commas rather than new lines, because if you just do print creature, you get line, then the next line, tiger, then crocodile, the next line, lion, next line, etc. So there's multiple ways of doing this. Suggested you can make use of the fact that you can combine two strings by adding. So that makes you think of the fact that you could do creature, which will be a string at any given point. If you've got a string like line, and you do add and the string comma and a space, that comes out as the combination of those two strings. So you could do something like that. However, if you simply, so you could make use of that, and as it suggests, you could do something like, so one approach is to use to print out, say, creature name plus literally a comma and a space, and then the print command by default prints something and then goes and then adds a new line so that to standard out so that the next thing that gets printed will get printed to the next line. But there's this optional specification for the print function in the end, which has, instead of ending in a new line, end with just an empty, actually a zero, not even a space, but just a null string. So don't go to the new line, but just end in a null string. So what that means is that in the first iteration, it will print the first creature plus a comma, line, comma. Second iteration, when it ends that print statement, it will not advance to the next line, but it will just stay at the current position of standard out. The next print statement, the next iteration of the loop will be the creature name, next creature name, which is tiger, plus a comma, etc. But that works apart from the fact that you have this comma at the end, because every single iteration you're ending in a comma after the creature name. So this is a bit weird. So if you don't want that, you can use a different approach. The approach suggested here is to use this totally different method, totally different approach. Don't even do a for loop. So it's saying, okay, string objects have a join method, which can be used to concatenate items in a list with the string in between. So for example, in other words, you just say, I've got this string, which is a, let's just call it something, comma string. It's superfluous, but just to be very explicit, comma string, call it something, is the string, because it's a comma and a space. Yeah? And now I'm going to say comma string dot, so I've got a string and doing a function call on that join, right? What is that function? Concatenate any number of strings, okay. So the input argument I'm going to give it is the entire list of animals, i.e. a list of those strings. And what it will return is a concatenation of the comma string with each of those elements in the list. So that in one go gets you what you want. Of course, maybe that's a bit not very satisfying if you were wanting to stick with a for loop. So one way to do it with a for loop was animals are defined as before. So just to be super explicit and have it all in one place, we define our animals as before. Actually, I'm just going to edit the same cell again to include the for loop. Now, before I start my for loop, I'm going to do a little starter, and there's just let's see something that there's going to be some new variable at that time. I'm going to call it something like animals list, and I'm going to initialize this with the first entry of the animals. So to begin with, before my for loop starts, that's going to already contain line. Then I say for creature in animals as before. The thing I want to do is, now what I'm doing is I'm building up this list, animals list. I'm adding to it, I'm saying animals list equals animals list, what it already was, which in the first iteration will be simply line, because we initialized that. Now I add the comma, then add the current creature. And what that means is simply because I've swapped things around so that essentially I've initialized with the creature, the first creature, and then I'm always adding a comma and the current creature. So I'm adding the comma retrospectively, if you like, rather than before the creature. So I'm adding the comma after the previous creature, rather than adding it after the current creature. So what that means is that at the final iteration of this loop, the final thing that gets printed is the final creature and not final comma. So I do that, and then outside the loop, after the loop is finished, indicated by not indenting, I say print the animal list to see how it's actually turned out. Okay, I've just made a mistake there. Animals list. Okay. So there's something I haven't taken care of, which is the fact that because I start now, I'm iterating. I've already initialized animals list to have a line to begin with. So I could restrict the range somehow. So I could restrict that to go from 1 until the very end. Okay, that would be the way to do it. So now I'm skipping the first creature, which I've already initialized animals list to contain, starting the first iteration of the loop at tiger instead of just at line. Okay, so that's one way to do it. So let's see. So let's talk about how we can use for loops to actually do some automatic data processing, to do something useful. So this survey CSV file that we've been using yesterday, today, has 25 years of data. I'd like to separate the data for each year into a separate file. So let's start by making a new directory inside the data folder. So I'm going to do something. So here you see that, okay, so I've said already that there's some commands that Jupyter Notebook or IPython kernel will recognize. They're not Python commands, but shell commands like ls. I've used that a few times already. So ls in data. So I've already created this directory in data called yearly files, but I'll just create it again. And if this was a Python script, or I was just using the bare Python interpreter interactively, not IPython or not Jupyter Notebook, what I would need to do is ls, so ls wouldn't work. And also what I can do is, in this magical IPython Jupyter Notebook approach, is just simply type make there if I was using the shell. But if I was using Python interpreter directly or Python script, that wouldn't work. What I need to do is I need to import the OS package. I need to do os.list there, for example. Let's do here. Right, I would need to use the OS package in order to be able to do these kind of things, and I can also create a directory using that command. Let's see what happens if the directory already exists. Yeah, directory already exists, so I'll complain about that. So I can create another directory. So I can do that, set everything up. And now let's import our data again. Let's see, do we already have? No, we don't. We haven't imported that. We haven't imported pandas even. Import pandas as PD. I'm going to save time by saying surveys df equals p.readscsv. Now I'm going to, so before we were reading in surveys 2001 and surveys 2002 from separate CSV files, but now we're simply going to extract those data frames as subsets of the full surveys data frame. So we're going to use our selection syntax, give me all the entries where the year is equal to 2002. We saw that you can do either the parentheses syntax or the dot attribute syntax for that. Okay, and then write that to file. Okay, so we've got more than 1 year, 2002, we've got lots of years in our data, right? So we basically would want to do this, we'd want to automate this somehow. So we want to create some kind of loop over years, and then for each iteration of that loop, do all of this processing for each year without having to write code for each year explicitly. So in order to create that loop, we first need to know what kind of years we need to iterate over. So let's have a look at our surveys data frame and what years do we actually have. So that's picking out our years data. But of course, any given year is repeated potentially many times, also records, survey records in any given year. So let's just use the unique method to give us a canonical list of the years that appear, each year that appears is only listed once in this list. It's a canonical list of the years. So this is a list we can iterate over, right? Let's store this. That would be useful. Let's call it years. Okay. All right, so this is something we can iterate over. So now we can create a for loop. We can say for year in, and I've simply already called it something, so I'm replacing, so it looks a bit different to what's in the example. For year in years, file name, build up a file name, which is, call it a string. The path, we want to store it. And then we're going to construct the file name based on a combination of a string that sets the path and the start of the file name. And the plus then, what we want is we want to include the year, the current year in this iteration. So this year is a loop variable that will change from 1977 to 1978, etc. as the loop iterates over the elements of years. Now that of course is a number. So let's just create a new separate cell here before I finish that, which is to say, what is the type of year, any given year? It's an integer, a 64-bit integer. So it's not a string, it's a 64-bit integer. Now here, in the example, it says explicitly cast this into a string. I'm just going to see what happens if I don't do that, because I think Python might do it automatically, but it's just to check. And then final string to complete the file name is .csv. Let's see what happens if it likes that. No. Okay, so it can only concatenate string, not numpy int64 to string. So you need to tell it explicitly, okay, I want you to make this in 64-bit integer year, our loop variable, make that into a string and then concatenate it. Now it's happy. Let me actually print out the file name during each iteration so that you can actually see what it's generating. Right, this looks good. This is what we want. So we've defined the file name where we want to store each subset of our data frame for each year. So what's the next step? what we've already read in the data. Now we're going to create our loop for year in years. Again, shorthand because I've already initialized years. Let's get the data for any given year, the data that we will want to write out for that year, which is the surveys DF subset based on the selection criteria that you can use the .year attribute or the parentheses notation is equal to what? The current year. And these are the same, you're comparing the same data types because we saw when we looked at the D types of the surveys data frame yesterday that the year field it was of type int64. So these are comparable, you can compare them and base the selection criteria on them being equal. So that's selecting the data for the year. Not added comments here, of course, it's good to add comments like this inside your code, inside your script. And then we're going to construct a file name in the way that we just had previously. So I'm just going to copy paste exactly what I wrote there in the previous loop. And then I'm actually going to write that data, surveys here for that year, to file, to CSV. And I'm going to give it now the file name that we've constructed. Okay, backspace to unindent, tell that the loop is finished. Tell that to finish that. Okay, so that's probably we don't get any output, but let's see what is in our yearly files directory. Okay, so it's created all these files. We should probably inspect that, confirm that. Let's just check that this data service is legitimately is correctly output. Let's see an arbitrary name. Let's say pd.read. Yearly files, surveys, 1982. Okay, does it look correct? The year is 1982. This looks reasonable. Again, the index starts at 0, but we don't necessarily care about that. Okay, so everything works as expected. This is just explaining how that was done. So we use plus to combine to concatenate strings. So yeah, have a go at this challenge. 5 minutes or so, and we'll look at it again at 10 to 12. Okay, so first part is some of the surveys have missing data, so they've got null values that show up as NaNs in the data frames. And because they're missing in the sense that missing rather than corrupted, so they're kind of just don't have any data rather than being weird values, so they don't show up in the text files. And they're interpreted by pandas as NaNs when they read the CSV file. Modify the for loop so that the entries with null values are not included in the yearly files when you output. So there's more than one way to do this. You could do some, explicit selection criteria. You construct some selection criteria based on whether it's true that any column for any, give me all the rows of the survey's data for that year, for which it is not the case that any column has a NaN. However, there's a quicker solution, which I think we used yesterday, where I can't exactly remember, but this drop NA function for a data frame. So basically, for any given year, so this is the line of code, essentially modifying the line of code within the for loop we had previously, right? For any given year, get the survey data for that year by selection criterion. But now we can add the additional function, the drop NA function. What does that do? And if you can see, just as a useful reference, sometimes when you're, if you've got if you want help for these functions to get the documentation, you can grab a literal instance of a data frame you have lying around, like surveys df, and then do the .drop NA. Or if you can't think of one, if you haven't created one, you just take the abstract sort of class, say the pd.dataframe, which is not an actual data frame you've created, but just a data frame class of functions called the record, called the help on that, with either help function or the question mark. No, the formatting is slightly different. Okay, so question mark, maybe a little bit easier to see. So yeah, this removes missing values. So maybe we included that already yesterday. Okay, so that will get rid of those rows. Then second question is, let's say you only want to look at data from a given multiple of years. Okay, so like every 5 years, say you want to skip. So you want to start at whatever the first year that you have data for is, and then every 5 years you want to extract that data from the survey data and then actually write it to file, starting from 1977. So we have our list of years, right? So we can start in 1977, and then somehow, yeah, this skip. We know how to write. So what we have as a for loop is for year in years do print year, right? What we want to do is actually just do something, not just necessarily print, but do something for that one, and then 1982, 1987, etc. Just basically skip. So what we can do there is we can use the range function. Now, range is a very useful function that's used in Python a lot. Just get the help on range. Range function, what does it do? It takes one or two or three input arguments, either just a stop or a start and a stop, or start and stop and a step, returns an object that produces a sequence of integers from start to stop, which are your input arguments, varying by step, which is the final input argument, which is defaults to a step of 1. In other words, if you have range I and j produces I plus 1, I plus 2, etc., all the way up into including j minus 1. So the default step size is 1. When step is given, it specifies the increment or decrement from one element to the next. So basically, range returns an object that is over which you can iterate in Python. It returns an iterable object. So what I can do is for I in range, so let's say 10, do print, no, sorry, not do, this is not bash or for, print I, right? So that just prints out starting at 0 up to including 9, so 10 minus 1. If I say start at 5 and end at 10, and do print I then, that will print 5 up to 10 minus 1. If I do for I in range, actually 5, 10, no, I'll start at 5, 10, and do a specify step size 2, say, print I. It will start at 5, increment by 2, print 7, increment by 2, print 9. So that's the increment thing that you want. So this is the kind of thing that we can use to iterate over. So what do we want? Well, we've got our years. So we will iterate over the first, you could say for I in range, so let's say now for year in range, the first, what is the earliest year we have is the first entry in that years array. So year 0, which was 1977, let's stop at years, the final one. What is the final entry? It's -1. Remember from yesterday, the indexing to get the final element of a list or data frame column. So -1, and what is the step size? Haha, 5. Now let's see if that works. Okay, this is something. We've got 1977, and then we skip to 1982 as we want. 1987, 1992, 1997. Actually, we know that we have data for the year 2002. Because if you look at this list of years, you see 2002, right, is the final year for which we have data, which should be in multiple of 5 because we have 1997 and then plus 5 is 2002. Why is it not included? It's because of this up to or including the final specification. So if we do up to and including the final value, let's say plus 1, and we could add a multiple of 5. It doesn't really matter as long as we include the final option. Right. So now we will iterate all the way to 2002 and include that in our multiple of 5. Right. This here relies, actually, this isn't completely, this could be an issue. I don't know if anybody spotted yet why this might be an issue. It could be an issue because this list of years was extracted from the survey's data frame. It happens to be ordered from earliest year to latest year because the records in that data file happened to be ordered. Right? We asked for the unique. As far as I know, asking for the unique year doesn't impose the ordering. The ordering is there because the years appeared in an ordered way. To be more specific, to be more general, to be able to handle cases where we've got a data frame that doesn't start with the earliest year for which we have data, but we still want that to be the earliest year to capture that. We could do, which is shown here in the example solution, which is to say, okay, let's make sure we've got the, let's say, earliest year equals years dot min. Okay, what is there for the earliest year? Okay, 1977. Okay, great. Latest year equals years dot max. Okay, that would be more robust. And then we could say, for year in range earliest year, latest year plus 1, increment by 5, print year, do whatever, right? So that's more robust, and that's why that includes min and max here in the example solution. Okay, that allows us to do the same thing we were doing before, but just every 5 years. Now, finally, instead of splitting out the data by years, somebody wants to do analysis and to analyze each species separately. How do you write a unique CSV file for each species across years with data for all the years, rather than a separate file for each year with data across all the species? Similar idea. Instead of constructing our list of years, we now construct our list of species. Now, unfortunately, species as the singular and plural for species is the same word. So this is a species list is, let's say, just like we did for the years. Now let's just create this intermediate variable that saves all the. So we're going to extract all the species IDs that are there. We're going to ignore nans by doing drop in A, and we're going to only get a canonical list with unique. We don't want replications of the same species ID. So that is a canonical list of our species. And now we can have a for loop where for species singular in species list. And we don't want to skip any, we just do all of them now. Extract the survey data, survey species data frame, where the species ID, it's always using this example using the attribute, but I prefer to use, we saw it slightly faster yesterday, I think, this notation, where that is equal to the particular species ID in the current iteration, then create the file name by combining that, and then I'm just copying and pasting because I know I realize we're 1 past 12, so I'm eating into your lunch, so to speak. Okay. And of course, That at the very least is incorrect. Okay, right. Okay, we'll leave it there, and we will come back for after lunch at 1 o'clock. You could start to have a look if you want at this functions bit, but yeah, we'll come back at 1 o'clock, so see you then.